Okay, so this is where we are, right? We've got F equals ma. Okay, and with force, one of the tricky things is that weight is a force, right? There's another tricky thing is that there's something called the net force. And so if I've got, say, 10 newtons this way, let's say it's an air track glider, it's resting on a frictionless surface, right? If there's 10 newtons that way and 3 newtons this way, what's the net force? 7 to the right. So this is where we're headed, is situations where we've got a force this way, a force that way, right? So really what this F means is that we add up all the forces in an intelligent way. And in this case, this guy's positive, this guy's negative, and we end up with positive 7 as our net force, right? Okay. And we can also have, by the way, we could also have a mass on a string. We could have some upward force. Remember that the downward force is going to be this force of gravity, this guy here, right? So here's my concept map, right? So if you have a mass hanging on a string, the downward force, the force down on the thing, is going to be the weight of it. And if this force is bigger than the weight, what's it going to do? It's going to accelerate up for sure, right? Okay. Whether it's going up or not, we'll talk about whether it has to necessarily go up, but it's going to definitely accelerate up, right? And what if this force is less than the weight? It's going to accelerate down. Okay. It could possibly go up in that situation, but it's going to accelerate down. For example, an elevator that's moving up and stopping, right? As it stops, the force of gravity is actually bigger than the force that's upward on. That's why it stops, right? Okay. So, yeah, we're going to look at situations like this and like this today. With mass, the only tricky thing is you better have mass in kilograms, right? So grams divided by 1,000, right, equals kilograms. And then apparently, right, the important thing is weight divided by 9.8 is mass as well, right? We just did that with this problem, right? So this is the only tricky thing about mass. And then with acceleration, everything applies to acceleration that always did, right? Its acceleration is change in velocity over time. It's VF is VI plus AT. It's, what is it? It's X is VI T plus 1/2 AT squared. It is also VF squared equals VI squared, right? So all of these A's, basically we might have you solve a how far problem to solve for what A is, yes? Does that make sense? So that's the crux there. So really, in the best of all worlds, in the best and most exciting of all worlds, we would have a problem where you had to solve a challenging yet meaningful how far problem to get the acceleration. I give you the mass in grams, no problem. You parry, you divide by 1,000, right? And then you've got more than one force acting on it. One of them is a weight, which you have to calculate, right? Isn't that exciting? Yes. Are you excited about where we're headed? Yeah, it's like, holy challenging problem, Batman. Okay, so that's the kind of forces that's where we're headed, is how to solve those problems. That's our little review.